Okay, today is May 19th. It's a Monday. This is period 7. Today we're studying amplitude of sinusoidal curves, and everyone in the room knows that they are being recorded.
What?
I didn't.
I'm being recorded.
I didn't know.
Shout out.
Now you know.
You're a liar.
Shout out.
Shout out.
It's Andre.
Andre. Shout
Yes.
out to Andre.
Shout out to me too.
Didn't I already shout out to you?
Do one more time.
Wepa.
Shout out to Amandi.
Love you.
Oh my God. Shout out to Jacob.
Do me again.
Yeah.
Do me again.
Okay, so
Deep.
I want to point out there are two different multipliers in these problems. All right, Amandi, now we're doing this. There are two different multipliers in these problems. So A, which is multiplied after the trig function, determines the amplitude. And amplitude is the same as a vertical stretch. And we covered that in 7.1. Now we've got the horizontal stretches, which is what's multiplied with the angle before you evaluate the trig function. And that's what we just covered a few minutes ago. Okay, so the number up front is the vertical stretch or compress. The number with the angle is the horizontal stretch or compress. And the vertical stretch is called the amplitude. It's the height of the wave. We're going to graph two problems together. So these are my two problems. So just write down problem 3, and then we're going to graph it together. Okay, so what's the amplitude for this problem?
It's going to be
4. All right, and the period
5.
is 2 pi over 5.
Okay.
Okay, now it's telling me to graph, and it doesn't say the interval over which I have to graph. So since this is going to complete one full cycle between 0 and 2 pi over 5, I'm just going to make life easier for myself, and I'm going to graph from negative 2 pi over 5 to positive 2 pi over 5.
Can I ask you a question?
Yes,
Why are you going from negative? Why don't you just start at 0?
I could if I wanted to,
Oh, okay.
because it's not telling me otherwise, so I could do it either way.
Oh, okay.
All right, so the way I'm doing it, you're going to see 2 cycles of the graph.
Okay.
All right, so now I've got a really hard question for you.
Mm-hmm.
What's half of 2 pi over 5?
1 something.
Wow, I didn't know you're being
1 pi
I
over?
know.
something.
No.
Would you have to put 1 pi? Couldn't you just be pi?
You could just be pi. What's half of 2 pi over 5?
Is it pi over 5?
Pi over 5.
That's half.
That's half. What's
Wow.
half
Oh,
of 2/5 pi, 1/5 pi?
Wait. Say it again now.
Pi over 5. Oh, okay. So half of this is pi over 10.
I'm so lost. Yeah, but half of 5 is not 10.
Think of it like this.
That's the opposite way.
Yeah.
So instead of cutting a pie, now this is pun intended, instead of cutting a pie in 5 slices,
Yes.
if you want half that amount, then you're going to cut the pie into 10 slices.
I get it now.
Think of it like,
Yes.
screw the pies. What if it's just 2/5? Half of 2/5 is 1/5.
It's 14.
So you just put the pie there. Feel me?
I got you. Thank you.
Mm-hmm.
You are so smart.
Thanks, bro.
Then it'd be pi over 2 would be the whole interval, which is, oh.
What?
The last variable for the
You watch the soccer.
for the x-axis would be 2 pi over 4,
Yes.
and then you just
Bro.
Half, right.
No one watches football.
All right, now I want to know what's halfway between pi over 5 and 2 pi over 5. What's halfway in between?
2.
Pi over
All right, I'm going to do that for you.
Isn't that just gonna?
It's going to be pi over 5 plus pi over 10. Okay, it's going to be this much plus
2 pi
this
over
interval
15.
more. So I need a common denominator. This is 2 pi over 10. No, you need a common denominator when you're adding fractions.
I'm so lost. Give me a second.
So it's 3 pi over 10.
What?
Damn, bro, you missed your game for that. Was it worth it?
Hold up. Where'd you go?
All right, so now I'm going to do the reflection across the y-axis and do all my negatives. So here I've got negative pi over 5, negative pi over 10, and negative 3 pi over 10. On the y-axis, the height of these waves are 4. So the maximum height will be at positive 4, the minimum height will be at negative 4. All right, so cosine is at its maximum at cosine of 0. Cosine of 0 is a maximum, so the height of the wave is 4. And then cosine has a 0 at the next interval. And then it comes to a minimum at pi over 5. Back to a 0, and then back to the maximum. So that would be one cycle of the graph. And then I'm just going to continue that pattern to the left so that you can see 2 cycles of the graph. So I've got a 0, a minimum, a 0, a maximum.
Sounds like stretching.
Oh, okay.
Stretching the graph as well, but
It's actually compressing. Because remember, this is happening 5 times over the course of 2 pi. But we've just labeled our graphs differently so that you can see this well.
I got you now.
Okay, so now problem 4. Here, since A is negative, it's a reflection across the x-axis. It's a vertical stretch of 3. And what's the period?
2 over 2.
Period is 2 pi over 2. All right, how would that be simplified?
1 pi.
Pi.
Or just, yeah, pi.
Okay. So let's set up our axes. I'm going to go from negative pi to positive pi. I'm going to go up on the y-axis to 3 and down to negative 3. What's half of pi? Pi over 2. What's half of pi over 2? Pi over 4.
I still don't understand this.
What's halfway between pi over 2 and pi?
Was it going to be 3 pi over 4?
3 pi over 4.
Oh, snap. Go, Andy.
Oh, I thought you meant like 5%.
That's me.
All right, now I'm going to do the
If you
reflections.
cannot pronounce the Andres, then you have to say Andy.
Oh, is that right?
Oh, that was a nice
Andres. Look, you okay over there, bud? You look like you're about to pass out. Okay.
All right, so now we're graphing a sine wave. Okay, so sine of 0 is 0.
So wait, this is not a sinusoidal curve?
Yes, both sine and cosine are both sinusoidal curves,
Oh.
but they are a phase shift. They end up on different points on the x-axis. So
Oh.
cosine starts at the maximum
Okay.
for cosine of 0. Sine starts at 0 for the sine of 0. All right, so now when I go to pi over 4, since this is a reflection across the x-axis, this is going to be a minimum. And then to 0, and then to the maximum, and then to 0. On the left, we're going to do maximum, 0, minimum, 0.